Good evening, and I welcome you, students, for a very important and amazing session. We have told you about the periodic classification of the elements, and I have told you that there are four groups. How many groups I told you? Four groups: S, P, D, and F. Right or wrong? Tell me. Did we tell you
Yes,
in the
sir.
periodic table four groups, students? How many groups were told, student? How many blocks? I'm talking of blocks, student. How many blocks were there in the
There
periodic
were
table?
four blocks.
S block, P block, student,
Yes, sir. D
D
block and
block,
F block.
and F block. Okay. So what is the basis of this? Why do we call anything S block? When the last electron enters into the S subshell or S orbital, what we call it? S block, right? The
Yes,
last
sir.
electron enters into S orbital. When the last electron enters into the P subshell or P orbital, we call it P block. When the last electron enters into D subshell, we call it D block. And you have seen the lanthanides and actinides students, they belong to F block. Today, our study is for S block element. I'll just take a moment, students. So today my study is for S block elements. I'm going to be talking about S block. And in the S block students, today I'm going to study the group 1. The S block means, student, as I said, S block means the last electron enter into the S orbital, into the S subshell. And how many electrons you can put in the S, tell me? Maximum number of electron in S can be how many, students?
Two.
S orbital, you know, there is only one S subshell and you can put maximum of two electrons, right?
Yes, sir.
Maximum of two electrons. Therefore, student, if I say n is the principal quantum number or n is the period number, as I say, then there will be ns1 and ns2. This ns1 is called group 1. This is the outer valence shell electron configuration. And this is called group 2, students. That means ns1, which I am saying is group 1, students. This is my outer वैलेंस आउटर शेल वैलेंस कॉन्फ़िगरेशन ठीक है राइट
Yes, sir.
सो स्टूडेंट्स व्हाट आई एम गोइंग टू डिस्कस इन दिस एस ब्लॉक द ग्रुप 1 student which are known as alkali metals. What are they called? Alkali metals. ठीक है. And first of all, we should know what I said, the last electron is entering into the outermost s orbital. Clear? Is it clear?
Yes, sir.
The outer valence electron configuration I am writing like ns1. Okay? So students, if you consider, it will start from the second period. Actually, hydrogen also has one electron in the s orbital, but we know that hydrogen is not an alkali metal. It has some properties of group 1 and some properties of group 17 also. So it is given a unique place in the periodic table. The first element is then, students, lithium, sodium, potassium, rubidium, cesium, francium. Is it clear, student? These are the
Yes, sir.
elements of group 1. These are called alkali metals. Clear? Or any doubt here?
No, sir.
Okay. So if I say that this will belong to second period, student, period number here is what? Second. Let me write it more in a better way so that you don't have any doubts, students. Second period, third period, fourth period, fifth, sixth, and seventh. This I'm putting a star on it. Can you tell me why did I put a star on the last element, student? Why
No,
did I
sir.
put a star on the last element, student? What could be the reason? This is a radioactive element.
Okay.
Radioactive element. What are radioactive elements, students? What are radioactive elements? You know that the nuclei of these elements are unstable. They have a half-life, student. What they have? Half-life. Why do I talk of half-life? Because they are emitting certain radiation, students. They are not stable. They are not stable, students. Therefore, these elements emit certain types of radiation, certain types of the radiation, students. And therefore, the study of these elements is not easy. And they are to be studied only in nuclear reaction, students, and also their abundance is also very very low in earth crust. Therefore, we are not going to study the chemistry of francium in our this chapter. That is a very these reactions do take place in the nuclear reactors, and we are not having much information about this. That is why I said it is radioactive. Even the occurrence in the lithosphere is very very small, student. 10 minus 18, which is available. That shows that they are so small, present in such a small amount. Therefore, the first question you will ask me, student, that why are these elements, first question, question one, why are, why are student group 1 elements which have outer outermost valence configured outer shell valence electronic configuration ns1, which have outer shell valence electron configuration ns. Why are they called student alkali metals? Called alkali metals. Can you tell me what could be the reason? What do you mean by alkali metal, student? First
Pardon,
question.
sir?
Why do we call these elements alkali metals? That is the first question.
Okay.
What do you think? What is the answer?
Mm,
What do you think could be the answer? Why are they called alkali metal, students? Group 1 elements. Why are they called alkali metals? All right, student. Here I am showing you something. Group 1 elements, they are called alkali metals. Student, lithium, sodium, potassium, rubidium, cesium, francium. See they are having very nice shining, these
okay.
elements. Lithium, soft, they are soft and have a good metallic luster. Have a good metallic luster. Lithium, sodium, potassium, rubidium, cesium, francium. This is how they look. They are solids, solids. Students, very soft, soft type of solids. Actually, what happens to students when these alkali metals they readily react with water. Alkali metals, students, they react with water, students.
Okay.
Their action is sometimes
Mostly with
sodium
water.
will explode in water. A very explosive reaction. When they react with water, students, they form alkalis. What do you mean by alkali, students? Hydroxides. What they are forming, students? Hydroxides. They are forming hydroxide, students, on reaction with water, which are basic, student. They are strong bases, students. If you have sodium hydroxide, you know it is a strong base. Is it?
No, sir.
So I say the solution will be alkaline.
क्या?
The solution will be alkaline, students. Alkaline means it will turn red, litmus blue. If you have a red litmus paper, it will turn blue. Therefore, students, because they react with water, they
Mm-hmm.
react with water and form hydroxides. These hydroxides are alkaline, hence they are named as alkali metals. They have been called as alkali metals. That is a group one I am talking about. Lithium, sodium, potassium, rubidium, cesium, and francium. Clear?
Yes, sir.
So sometimes they ask a question. Sodium and potassium are sixth and seventh most abundant elements, student. If I say their abundance, students, where they are available, student, in the crust of the earth, in the crust of the earth, you will find them. Sodium, potassium are sixth and seventh most abundant elements. 2.6 to 2.5% of the earth crust, where they are in earth crust. You are aware of the lithosphere, the crust of the earth, student, and they are 2.6 to 2.4% of the earth crust. That's quite a large value. Other alkali metals are rarer. These are rarer, students, rubidium, cesium, francium, and 0.03, 0.007, and 0.00% of the earth crust. Francium is natural radioactive isotope and is rare, very rare.
Okay.
Fr was discovered only in 1939, student. It is highly radioactive. Its longest lived isotope has a half-life of 20. Francium is radioactive 223, students. 87 is the atomic number. It has a half-life of how much? 21 minutes. What it means? That in 21 minutes, half of this will disappear. It will disappear, student. What do you mean by half-life? You are aware of this. So, what you find, student, these elements, these are present in very, very small amounts. Okay, you have information. Let us see the relative abundance which is given in this table, student. Relative abundance. What do you mean by abundance? Lithium is 0.0018% of earth crust. Sodium is 2.27. Potassium. These two are much larger. Rubidium, cesium. See, francium we have not given is very, very small amount here. And where how they are obtained, student, some information about the mineral source also. You know that there are ores, minerals from which we get these metals. Lithium, the name of that is lithium aluminum sulfide. That is called spodumene. Sodium NaCl, you know, rock salt. You have seen rock salt. Rock salt you have seen, student, already. Salt
Yes,
like
sir.
rock. You have seen sometimes, students, in a Tonga, there is a person who is selling these rock salt, big, big pieces. Did you see that? People are using it for some purpose, hot water bath or whatever they are taking. Rock salt, potassium, sylvite. No sources are well known for these, students. So you can see the relative abundance also. The important point is, student, electronic configuration. This is a very important point. So what are the atomic numbers, students? Atomic number. Lithium is 3. Sodium, if I add 8, how I add, student? Magic number 8, 11. Potassium, what is the atomic number of potassium? Then you add another 8, student. Another 8 potassium you will get. ठीक है? Add 8, student, you will get 19. Lithium, sodium, potassium, rubidium, you add 18. What will you get? 37. Lithium, sodium, potassium. This is Rb. I'm saying, students, rubidium. Add another 18. What you will get? Cesium. 18 plus 37. What will be that? 55. Then you add 32. What will be the answer? 87 francium. These are called magic numbers by which I can. Do you understand magic numbers? 8, 8, 18, 18, 32. Note it down. Note it down. ठीक है?
हाँ सर.
Okay, let's see how I will write the electronic configuration of these elements, student. They may ask you in the paper. This is radioactive. We are not interested to study much about it. Tell me the period number. Students, what is the period number? What is the period number of which period is lithium? Which period the lithium is in the periodic table? Tell me. The valence shell electronic configuration NS1. NS1. What is the period number of lithium? Tell me. You have been told about the periodic table. You have learned the periodic table.
Yes sir.
What is the period number of lithium? 2. Sodium belongs to third period, potassium fourth period, fifth, sixth, seventh. Is it right? Tell me. Are these period number right, students? What I have written? Yes. So students, here this is the value of n. Period number is the value of n. That is the value of the last shell, students. N is equal to 2, 3, 4. This is my n here. So students, with this information, we can easily write the electronic configuration, students. Period number, student, is very, very important. N value. N value is nothing but the period number, student. This n is the period number. Period number. If n is 2 for lithium, the last shell will be what? N equal to 2 means 2s1. Atomic number is 3. Then what will be the first one? 1s2, 2s1. So this is the electronic configuration of lithium, students. Okay. Yet period number 3 means what is the last one? 3s1. And then you have seen, we have given you how to write the electron configuration. What will be the, how many are there? 11. So 2, before 3s you have 2p, you have 2s, you have 1s. How many electrons you put in 2p, student? 6 maximum. 2, 2. How much is this now? Tell me. हो गया 11? Tell me. And what about this, student? This is a noble gas configuration. This I should say 1s2, 2s1. ठीक है? This 1s2 is what? Helium, noble gas configuration. So I may write to S1, student. What is this? If I add 8 in this, it will, which noble gas is this? Helium. After helium is neon. So you can write 3s1, student. That is the same thing. This is the same thing. Another easier way of writing these configurations. What will be potassium? 4s1 will be the last one, fourth period. Then you will have to write the other one, student. There will be 3p. There will be 3s, 3p, 3s, students. Then 2p, 2s, and 1s. How many electrons put? How many you can put in S2? 2, 6, 2, 6. Does that make 19? Tell me, count it. Count it, students. This is, you can see how I write the electronic configurations. After, if I write in terms of this, add 8, 18, argon. 18 is the noble gas configuration, argon, student. And you have 4s1. So I can write it like this. I can write the configuration like this. Yes or no? Tell me. So similarly, I can write for all student 8, 10, 18. This is 18. Then you have next one 36, helium, neon, argon, krypton student. And then what it will be? 5s1, add 18. What will you get? 54. Helium, neon, argon, krypton, xenon students. 6s1. And like this, you can write the electronic configuration. Add 32 students. What will be that? 36 will be 86. That will be radon. 7s1. Now you see, how do I write the electronic configuration? Any doubt? Tell me.
No, sir.
Can you write this? I can complete this by this method. The last shell is 5s1, and then you have to write the inner shell student, inner shells. This is coming like this. Therefore, students, lithium, sodium, potassium, rubidium, cesium, francium. This is the way we write their electronic configuration. You have noted down, then I will proceed further, students. Noted? Can I proceed further, students? Okay. What's the atomic and ionic radii of these students? The group 1 students elements you say the outer valence shell electron configuration is ns1. Okay? They have one electron in the outermost s subshell. Is it clear?
Yes, sir.
After, before that, they have a noble gas configuration. So if I say noble gas and ns1, that will be okay, right?
Yes, sir.
What happens to the size, student? As you go down the group, students, from lithium to lithium, sodium, potassium, rubidium, cesium student, what we find? Atomic size increases. Atomic size increases. Why the atomic size will increase, students? Tell me. What is the reason for this? Going down the group, atomic size increases. What is the reason for this, students? You already know the answer. In fact, in the periodic table, that alkali metals have the largest size. They have the largest size, students. What is happening? You are increasing as you go down the group, student. What is happening, student? As you go down the group, the number of electron shell increases. Yes or no? Number
Yes, sir.
of electron shell increases down the group. Yes or no? And value is increasing. First, lithium. What if lithium? You are saying it is a lithium has only 2 shells. You have seen just now 1s2, 2s1. This is my first shell. This is my second shell. It has only 2 shells. Here you have third shell, and this is n equal to 2 shells. N equal to 3 shells. This has n equal to 4 shells. This has n equal to 5 shells. This has 6 shells. So down the group, the number of shells is increasing, student. Yes or no? Increasing. For what happens then? There is only one electron in the outermost s orbital. Only one. Then inners are completely filled, students. What they do? These inner electrons shield the nuclear charge for the outer electron. Therefore, outer electron is not experiencing the intense nuclear charge equal to the atomic number, but much less than that. Much less than that. Therefore, the outer electron is not strongly attracted by the nucleus, students. Hence, it is going away from the nucleus with increase in number of shells. And also there are electron repulsions between those filled electrons. They try to push the outer electron away. Nucleus tries to pull the electrons to itself. The result is, as you go down the group, there is an increase in size. So I can conclude what I can conclude. Since the number in, I am saying that therefore the only factor which affects the atomic radius of alkali metal is the number of electron shells, students. As the number of electron shell increases down the group, atomic size increases. Okay, right? Clear? Bolo, any doubt? What will happen to the ionic radii, student? What do you mean by ionic radii? They are having one electron in the outer shell, student. If M is the metal, student, you are saying the electronic configuration is noble gas NS1. If I form M plus ion, if I form ion, student, what will happen? It will be left only with the noble gas. This electron will be ionized, will leave, student. So what will you get? Noble gas. ठीक है? This is why I'm writing M plus, student. After they lose one electron. So you will get M plus, lithium plus, sodium plus, potassium plus. So what will happen? The size of cation is always smaller than the neutral atom. We have studied that. So here we have given the atomic sizes, student. This is 1.23 angstrom. This is 0.68, 1.7, 0.98. So ionic radii is always smaller than, students, the atomic radii for a cation, M plus ion. Is it okay? Down the group, it is increasing. Down the group, ionic radii and atomic size increases. What is happening down the group? Atomic size and ionic radii increase. Is it okay, students? ठीक है? Any doubt? Can I proceed further? Tell me, should I go further? You have noted down everything? Tell me yes or no, students. Can I proceed further? Noted everything?
Yes, sir.
Okay. Next, student, ionization enthalpy. What is ionization enthalpy, students? What is ionization enthalpy, student? Here I am saying first ionization enthalpy because I am removing one electron. After one electron is removed, they become noble gas configuration, students. Then it will be very difficult to remove the second electron. A lot of energy will be required. So what we are saying, this is my metal, student. In the gas state, I am removing one electron, students. And that is my first ionization energy. Tell me, down the group, ionization energy will increase or decrease, students? What will happen down the group? If I go down the group, students, what will happen to the ionization energy? It will increase or decrease? First ionization energy. Down the group, first ionization energy decreases, student, because atomic size increases. Clear? Is it okay?
Yes, sir.
Size will become more. The outer electron will go farther away from the nucleus. Then the attractive force is less, and it will be requiring less energy to remove the outer electron. In general, I can say, student, ionization energy is inversely proportional to atomic radius. Note it down, important point, student. Inversely proportional to atomic radius. Atomic radius increases, ionization energy decreases, students. Values are given in kilojoules per mole, student. Lithium has the highest ionization energy, 520, then 495, 418, 403. It is decreasing down the group. You can see these are the first ionization energy, student. They are decreasing down the group. What is happening? Decreasing. Are they decreasing? Tell me. Yes or no?
Yes, sir.
Okay, here is a graph of ionization enthalpy versus atomic number, students. We can plot, student. These are units are kilojoule per mole. So lithium has the highest value. Then it is decreasing, decreasing, decreasing. You can see that decrease. Tell me, ionization enthalpy. This is our these are the first ionization energy, student. These are the atomic number. Atomic number. So with increase in atomic number, the value is decreasing. Okay? As atomic number increases, students, what is happening? As atomic number increases, ionization enthalpy. This is my first ionization enthalpy decreases, students. Clear? Any doubt? Note it down everything, students. You must learn everything important. Note it down, students. Noted. Can I proceed further, students? All right. Next time talking of hydration enthalpy, students.
Yes,
What
sir.
is hydration enthalpy? Can you tell me what is hydration enthalpy, students? What is hydration enthalpy, students?
Uh, the
Yeah.
amount of energy needed
If you if you
for
put them in water,
hydration.
student, water, you have water here, x moles supposing, then what happens? It becomes, student, mx aqueous. Aqueous means this metal ion gets surrounded by water molecule, student. And what happens then? This energy is released, student. What we talk of? Negative. This is always released, student. Whenever metal ion is surrounded by not one, there will be many water molecules which will surround the metal ion, student. As more and more water molecules will surround, there will be a attractive interactions. Why? देखो, you have m plus, there is a charge density, student. Charge density. Larger the charge density means more the charge, smaller the size, smaller the size. More intense the charge, smaller the size. What will happen? There will be more water molecules which will surround it, student. This is negative, this is positive. This is what will happen. Lot of water molecules are going to come, student. This oxygen is negative, student. Oxygen is negative. ठीक है? Negative positive. H positive student. Many molecules, not one, are coming. What will happen? Due to these attractive interactions, what will happen? Attractive interactions taking place. Bolo, there will be electrostatic attractive forces,
Yes, sir.
positive, negative. So they will release student energy in the form of heat.
Yes, sir.
So smaller the size, students, smaller the size, more the water molecules which will surround them, attract, and more will be the hydration enthalpy. Therefore, student, which will have the largest hydration enthalpy, if I take Li plus Na plus lithium, sodium, potassium plus rubidium plus, tell me which is the smallest ion? Which is the smallest ion? This is the smallest ion.
Yes, sir.
So this will be surrounded by more water molecules, and therefore more hydration enthalpy, more energy will be released in this case.
Yes,
Therefore,
sir.
the hydration enthalpy decreases with increase in ionic sizes, student. This is the order of the hydration enthalpies. This is the order of the hydration enthalpy. That means, students, lithium in gaseous state is smallest in size. But in aqueous water, lithium becomes the largest in size, student. And if I will measure the conductivity, it will become less because the hydrated lithium ion is largest in size. What I am saying, lithium plus gaseous, smallest in size. But I am saying lithium plus aqueous, hydrated, hydrated lithium ion, hydrated ion, this will become largest in size. Yes or no? Because it will be surrounded by more water molecules. Therefore, its conductivity will then decrease. Conductivity, because the iron become more highly hydrated, student, its size has increased. The conductivity wise, it will be the smallest conductivity because of the large hydration spheres around it. Large number of water molecules are surrounding this Li plus. Is it clear?
Yes,
So
sir.
they will ask you in the paper, arrange them according to decreasing hydration enthalpy question. Arrange in, supposing I say, increasing order of hydration enthalpy, students. Lithium plus, sodium plus, potassium plus, rubidium plus, cesium plus. What is your answer? Increasing order. Which is at the highest
Yes,
hydration
sir.
enthalpy? Tell me in this. Which has the highest? Lithium plus has the highest. Then sodium plus, then potassium plus, then rubidium plus, then cesium plus. Is it okay?
Yes, sir.
Then in aqueous medium, this become largest in size. The values are given here: minus 506, minus 406, 330, 310, 276. So as you can see, that they are decreasing, student. These are delta hydration enthalpies, student. They are negative, all are negative, you see, negative, because this heat will be evolved. Therefore, student, the tendency of hydration is highest in lithium plus. This is the most hydrated because of the smallest size, student, high charge by radius ratio. That is called the density. High charge by surface area, charge density. So much so that lithium salts, student, lithium salts are mostly hydrated, student, are mostly hydrated. For example, LiCl exists as this. It is a hydrated salt. It has got water molecules present in it, students. So lithium has a strong tendency for hydration, and forms hydrated salt. Students, note down so that we proceed further, students. Is it clear?
Yes, sir.
Okay. Here are some of the physical properties, student, physical properties of alkali metal. What do you mean by physical properties, students? Atomic radius, you can see increasing down the group. Ionic radii, increasing down the group. Melting point, student. What do you find? Their melting point, students, they are given in degree Celsius. Actually,
Mm.
alkali metals are soft
Yes, sir.
and have low melting points. And melting points are decreasing down the group. Number one. Number two, melting points decreasing down the group. Now we have to explain, students, why the melting points are low for the alkali metal. Transition elements have very high melting point. You know, iron, copper, gold, silver have high melting point. Why they have lower melting point, student? They are soft. You can cut them with knife. You can cut them with knife, student. Why they have low melting point, student? Melting means what? There is some attractive force between these. They are metals. There is a metallic bond, student. What is there? Metallic bond
Okay.
between the atoms, student, between the metals. For example, if M is a metal, you are saying that it has one electron is loose, student. It exists in this form. This is called the kernel, student, and there are free. These are the free electrons. And the attractive force between them depends on the presence of these electrons. The attractive force, student, or the metallic bond depends on students the number of these free electrons, number of free electrons. If there are more electrons, student, there is a stronger attractive bond between them. The metallic bond is strong if there are more electrons. They have only one electron. They have only one electron, student, to lose, right? They are existing like this in the solid form. Yes or no? So the metallic bond is weak, student. Therefore, if metallic bond is weak, then energy to melt will also be less, students. Therefore, they are soft as compared to transition elements because they are having stronger metallic bond, student. Here the metallic bond is weak as there are only one free electron per atom, student, because the electron configuration you have seen, they have one outermost electron in the s orbital. Is it clear? Therefore, you will see, and as you go down the group, student, number fourth question is, as you go down the group, melting point decreases. Why? Down the group, students, melting point decreases. Why it decreases? Why it decreases? Because the size of the ion is increasing.
Yes, sir.
And when the size will become more, student, the attractive force between the kernel and the electron is less, student. If smaller the ion, student, smaller the ion, the stronger is the charge on it, student. The charge is higher, student. Attractive force is stronger. The metallic bond becomes stronger, student, when they are smaller in size. So as the size will become more and more, the metallic bond will become weak. Down the group, melting point decreases as metallic bond becomes weaker, student, due to increase in size of M plus. Okay,
Mm.
noted.
Yes, sir.
Melting points. Then second, I am coming to the boiling point, student. What is happening to the boiling points? Their boiling points are also low, and as you can see, boiling points and melting points are low, student, as compared to others. Iron, transition element, copper, silver, gold, they have very high melting and boiling point, student, and it decreasing, as you can see, decreasing down the group. Some variation is there, almost same, because once you have melted it, student, you have broken the metallic bond already. So what you see, these boiling points are low and decreases in on an average down the group in general, student, again because their sizes are increasing, therefore you will see the decrease in boiling point. Then first ionization enthalpy we have already explained. It is inversely proportional to the atomic size, student, always. Bigger the size, smaller the ionization enthalpy, as you can see in this case. Decreasing kilojoules per mole. Noted? Have you noted it? Tell me. Each and everything you note down, so I proceed further. Noted? Next property, electronegativity, student. What is electronegativity? Tell me. What do you mean by electronegativity? Are they electronegative element? Tell me yes or no. Are they electronegative element? Yes or no? Answer me. They want to attract electron or lose electron? Tell me. What do you say? These are alkali metals. You already know, student. They have one
Yes,
electron
sir.
extra. They want to give an electron. This will become noble gas. So they have very low electronegativity. They are electropositive, students. They are.
Yes, sir.
They'll want to lose electron, students. Their electronegativity is very small, even smaller than carbon. If I see the Pauling scale, student, Pauling scale, this is a very low value. You know, fluorine has got value of 4 Pauling scale, which is strongly electronegative. So left side you have the weakest, least electronegative. They are not electronegative, they are electropositive. They are metals, student, they are metal. Metals are not electronegative. Non-metals are electronegative. And as you go
Okay.
down the group further, what happens? Electronegativity decreases. Decreasing further. That means, student, metallic character is increasing. Metallic character is, because the size is increasing. Size is increasing.
Okay.
Smaller the size, more nucleus will attract the outer electron. Bigger the size, the outer electron is away from the nucleus. Student, less electronegative. So you can see they are electropositive. They are not electron negative elements. We know about it. Therefore, as you can see, student, even in the same group, electronegativity decreasing. Density, students. What is the density? What it shows? Gram per centimeter cube, student. Gram per
Yes, sir.
centimeter cube. Water density, you know what is the density of the water? What is the density of the water? Students, tell me. Tell me what is the density of the water? Water density, you are saying 1 gram per centimeter cube.
Yeah.
And this, they have, their density is less than that. They will float on water. They will float on water. See,
Yes, sir.
this density is less. And here density is more. So it will just
They will
sink in the
sink.
water. But since they react with the water, if they react with the water, what they do? They form hydroxides. And what will happen then? Hydrogen gas, if liberated, will push it up, push it up. Even in the water, you will see they will catch fire in the water. They are having explosive reactions. So student, density is defined as mass per unit volume. Since their volume is the largest, they are the largest in size, student, their densities are less. Their densities are less, students. So as you can see, as compared to other transition and other metals, what we are showing further, student, ninth, standard enthalpies. What do you mean by standard enthalpy value, students? Their values are very negative. What it means? M plus aqueous plus an electron student. This E naught value, what you see is highly negative. Highly negative. Is it negative? Tell me. Minus
Yes, sir.
3.04, minus 2.7. Therefore, students, they do not want to gain electron, they will lose electron, reverse. They are very good reducing agents, students. In fact, they are the strongest reducing agents. What are they?
Okay. Strongest reducing agent.
Reducing agent means these are metals, students. If you put in water or acid, they will liberate hydrogen. They will liberate hydrogen because they will give electrons. They will give electrons. If you have H plus, if you give electron to this, what will happen? Hydrogen gas will be liberated, student. See, so hydrogen, they will liberate hydrogen gas, student, from water and acids. So they are strong reducing agent. They are acting as strong reducing agent, students. Alkali metals are acting as very good reducing agent, very important. They have very high values of the, you can see that the strongest reducing agent is lithium plus maximum. Which is the strongest reducing agent? Strongest reducing agent is Li plus. Why? This depends on what? It depends on the ionization enthalpy, atomization energy, and it also depends on the hydration enthalpy, students. The hydration enthalpy of lithium is largest. You have seen it because of the smallest size. You know that Li plus has the largest hydration enthalpy. Clear? Is it right? Therefore, students, the standard electrode potential values depend on many factors. Ionization energy, student, enthalpy of atomization or sublimation energy, and hydration enthalpy. You see lithium has the highest hydration enthalpy, lithium. See that? Minus 506 kilojoule per mole because of the smallest size, student, because lithium plus is the smallest size ion. Charge density is very high, student. Therefore, hydration enthalpy of lithium plus is highest. Therefore, lithium plus is the strongest reducing agent. Clear? Noted? Have
Yes,
you
sir.
noted everything? Tell me, students. Noted? Any doubt? Is there any doubt, students? Therefore, students, I can say that. What I can say. Alkali metals are extremely soft, readily fused. They are highly malleable, ductile, can be cut and to sheet because they easily lose electron, student. Their ionization energy is low, size large, student, and after this they get noble gas, student. Therefore, student, due to these free electrons, they are ductile, they have metallic luster, they are soft, they have low melting points, low boiling points, student. They can be cut into sheets. Their densities are quite low. Lithium, sodium, potassium are lighter than water. Densities increase with increasing atomic number. However, potassium is lighter than sodium. Important point. K is lighter than sodium. Now, what is the reason? Density depends on the mass per unit volume. Mass per unit volume. The mass of potassium is more than sodium, but then volume becomes more. Volume becomes more. If volume of potassium is more, student, why? Because if you see the electronic configuration of sodium, what is sodium is second period. Second period. What is this sodium? Helium. Uh, Sodium is 11. 11 is your neon, and you have one this is third shell 3s1 student. And what about potassium? Lithium second period, third period, and potassium. Potassium, what is the potassium student? Electronic configuration of potassium. You have seen potassium is 4s1. But before 4s, there will be a vacant 3D subshell also. Therefore, student, what happens? The volume becomes more. Volume of potassium is more. Hence, exception, the density of potassium is less. Density of potassium is less, student. Density of potassium is less than sodium. This is an exception. It is not an exception, but we have explained it by using, because the volume becomes more, student, in this case. See there are vacant subshells, 3D subshells in the case of potassium, which are not there in the case of sodium. If you see the electronic configuration. If I see the electronic configuration again, student, then you will be getting this answer more clearly. Important question. Important question. Where is the electronic configuration? Which will see sodium is 1s2, 2s2, 2p6. This is filled. Then the third shell start. But here, first cell, second, and 3s2, 3p, and there in the third shell 3d is also there, student, which is vacant. Vacant in the case of potassium, because there is nothing in 3d, 0 is there. So this will also occupy volume, student.
Yes,
volume. So the volume of potassium will become more. Volume of potassium will be more than volume of sodium, as there is a vacant 3d subshell in potassium. Therefore, the density of potassium, important question have been asked in paper, density of potassium becomes less than sodium. Whereas down the group, density is increasing. Down the group, density is increasing. As you can see, student, the values which we are giving, as you go down the group, density increases, but exception which you see here, the density of potassium is less than sodium, because the volume of potassium is more. As you can see, there is a vacant 3D orbital, student, in the case of potassium. Clear? Okay. Do you understand? Tell me.
Yes, sir.
Okay, then here we have shown you some of the physical properties and important points about this key densities, melting points, student, boiling points, and also we have shown you the physical properties. Their melting boiling points are low, student, ionization very low, and electropositive, they are highly electropositive, and therefore strong metal. Photoelectric effect means they can easily lose one electron, student, because their ionization energy is low. So they will, electron can be easily ejected from this by the light energy, That is why they show metallic luster, student, metallic luster. And they will show photoelectric effect. They can be used in the photovoltaic cells. They can be used in the cesium is used in the photovoltaic cell, because it has a very, very low ionization energy. Okay, then we are ending up the lecture here, and then we will see you in our next class further with more properties of the S block elements, alkali metals. Okay, then good night. Then I will see you in the next class. Okay.
Yes, sir.
All right.